Welcome to The Explainer. Today, we're diving headfirst into the ultimate detective story of the void. We are going to figure out if quantum mechanics uses complex numbers just out of sheer mathematical convenience, or if it's actually a strict physical necessity. For decades, physics students have been taught that the universe operates on complex amplitudes, but they're almost never told why. Is it just a neat math trick that happens to work, or is it an unavoidable law of reality? Well, today, we're breaking down the Division Algebra Theorem to see exactly how the universe systematically eliminates every other mathematical option until literally only one remains.
So let's dive right into this central mystery. And as we do, keep in mind that physics isn't always about choosing the right math. Actually, it's about eliminating what is forbidden until only a single answer survives. When we ask why the universe requires complex amplitudes, we're really looking at a framework where the universe doesn't just pick structures off a menu. It enforces strict prohibitions. It's a massive process of elimination. The mathematical structure we're left with isn't selected because it's pretty or elegant. It's the unique, unavoidable residue of strict physical constraints.
Section 1. The suspects, Frobenius's candidates.
To start our investigation, we need to bring in a mathematical rule from all the way back in 1877 known as Frobenius' Theorem. This theorem demands that our scalar field, which is just the algebra of weights assigned to independent continuation amplitudes in the universe, must be a finite-dimensional division algebra over real numbers. Now, out of all the infinite mathematical structures we could possibly dream up, that rule narrows the field down to exactly three viable suspects. We've got the one-dimensional real numbers, the two-dimensional complex numbers, and the four-dimensional Quaternions. One of these is the fundamental scalar field of our universe. The other two? They're about to be systematically eliminated.
Section 2. The rules of the void, C5 and C1a. Right, before we can interrogate our three candidates, we have to establish the two primitive constraints, the prohibitions, that govern the physical universe. The first one is constraint C5. This constraint dictates that the universe requires a strict minimum of 2 irreducible degrees of freedom for any event to be observable. Basically, it means that any physical event has to simultaneously carry a where it's going, like a continuous spatial propagation, and a where it's been, a temporal residue left in history. If a mathematical structure can't intrinsically hold both of those pieces of information at the exact same time, it simply cannot represent a physical event in our universe.
And that brings us to our second prohibition, constraint C1a, or independence preservation. This just means that for independent events, the order of operations absolutely cannot change the outcome. Think of it kind of like putting on your socks and then your shoes. In a truly independent system, the order shouldn't matter, though obviously, good luck putting your shoes on first in real life. But mathematically, this is expressed as the commutator equaling 0. The commutator of T sub A and T sub B equals 0. Independent distinctions must remain independently continuable without forcing some hidden arbitrary ordering on the universe.
Section 3. Suspect 1. Eliminating real numbers.
Okay, let's see how our very first suspect, the real numbers, holds up against those constraints. Now, real numbers are definitely the most intuitive to us, but they only allow for discrete phase flipping. You have a positive number, or you multiply by -1 to flip it, but that is a hard, discrete jump. They completely lack the structural dimension to encode the continuous phase rotation, that smooth spatial propagation that constraint C5 absolutely demands. To get that continuous circle of phase, which is known in group theory as U1, you strictly need a second independent degree of freedom. Real numbers only give you one dimension, magnitude. So because they can't encode simultaneous propagation and residue, they're out, eliminated.
Section 4. Suspect 2. Eliminating Quaternions.
Let's move on to our four-dimensional suspect, the Quaternions. Now these give us more than enough dimensions to handle the 2 degrees of freedom required by C5, so why not just use them? Why doesn't the universe run on four-dimensional amplitudes? Well, here's the catch. Quaternions are famously non-commutative. In Quaternion math, multiplying A by B gives you a completely different result than multiplying B by A. For instance, the basis element I times j equals k, but j times I equals -k. This order dependence instantly breaks the physical law that independent events must remain independent. If the universe actually used Quaternions for its scalar field, the joint state of two independent systems would depend entirely on which one you decided to mathematically update first. Any attempt to force Quaternions to work means you'd have to add completely arbitrary, unlicensed ordering rules to the universe. You would basically have to artificially tell reality, hey, always calculate subsystem A before subsystem B. But true physical independence means no such ordering can possibly exist. Because every faithful representation of Quaternions contains this non-commutative flaw, they violently clash with the C1I independence preservation constraint. So Quaternions, they are strictly forbidden.
Section 5. The survivor. Complex numbers.
So, with reals being too small to hold the complexity of physical change, and Quaternions being way too tangled to allow for true independence, we are left with exactly one mathematical survivor. Complex numbers perfectly thread the needle here. They provide exactly the 2 degrees of freedom needed for constraint C5, giving us both magnitude and a continuous phase rotation circle. And at the same time, unlike our Quaternion friends, complex numbers are perfectly commutative. A times B equals B times A. This means they satisfy constraint C1A, allowing independent physical systems to evolve without artificially forcing any order of operations on them.
The crucial takeaway here is that the universe uses exactly 2 dimensions, the complex numbers, because the minimal compilation principle demands the absolute simplest structure with 0 unconstrained, leftover degrees of freedom. We know the universe needs at least 2 dimensions for continuous phase rotation. We just saw how 4 dimensions completely breaks independence. So the complex numbers give us exactly 2. It's truly mind-blowing when you sit back and think about it. This isn't some arbitrary choice. It's literally the unique mathematical structure that survives the strict physical constraints of reality.
Section 6. The universal structural spine.
But here is the massive twist in our detective story. The exact same rule that eliminated Quaternions is actually the secret architecture underlying all of reality. This single, simple equation governing independence isn't just about scalar math, it cascades across multiple layers of the universe. When we say the commutator of T sub A and T sub B equals 0, we're really looking at the algebraic shadow of a deep, fundamental physical truth. Independent systems cannot secretly coordinate with one another. If they did, they literally wouldn't be independent, and the universe rigorously enforces this lack of coordination at every single scale.
Let's look at how this independence constraint acts as a structural spine. A single mathematical axiom simultaneously compiles conservation laws, forces complex scalar fields, and factorizes the gauge groups of the standard model. One single prohibition, no hidden coordination, manifests in 3 entirely distinct ways. At the transition level, it blocks coordinated fluctuations, which we experience directly as local conservation laws. At the scalar level, it completely eliminates Quaternions, forcing complex numbers. And at the symmetry level, it forces independent physical forces to commute, creating the incredibly specific gauge structure of particle physics.
Whether it's preventing hidden coordination in state transitions or dictating the product gauge structure of particle physics, this one constraint is the absolute structural spine of the framework. Look at how beautifully all of this lines up across the board. Dynamics, scalars, symmetry. All 3 domains are entirely governed by the exact same algebraic consequence. Independent objects simply cannot force an order upon one another.
Ultimately, physical laws like conservation aren't actually about protecting objects. They exist because the geometry of the universe just flat out forbids certain directions of change. When we see a conserved quantity, like energy or momentum, it's not because the universe is keeping some protective ledger of stuff. It's because a change in that quantity would require a forbidden, coordinated transformation that fundamentally violates the structural spine of independence.
I really hope this explainer leaves you wondering how many other fundamental pieces of reality are just inevitable survivors of the universe's strict prohibitions. We just saw how complex numbers aren't some human invention artificially mapped onto quantum mechanics. They are literally the only math allowed to exist by the rules of physical independence. It kind of makes you look at the rest of the standard model and ask, what else is just a residue of the void? Thanks so much for joining us on this one, and keep questioning the foundations.